Okay, part 2 of chapter 6 for chemistry. So we are on balancing chemical equations. Now, the great thing is we did this in class last week, and we practiced how to balance the chemical equations. I'm on the wrong chapter of the book. Let's go back. I was planning next week. Okay, so we practiced balancing the chemical equations. So the basic part of balancing them, I think you'll be fine with. You count the numbers on each side, then you add coefficients. Never change the subscripts, but you add coefficients. So, example 6.2. Got a marker, guys. Okay. Example 6.2. We have C6H12O6. That is sugar. Let's turn the board the other way because that's not going to be enough room. C6H12O6 plus O2 become, it actually is already balanced, or maybe 6CO2 plus 6H2O. So we count each side. Carbon, there are 6. Hydrogen, there are 12. Oxygen, there are 6. Then we multiply the 5 by the 2, so there's 10. So there's 16. Carbon, there's 6. Hydrogen, 6 times 2 makes 12. Oxygen, 6 times 2 makes 12. Plus 6 more makes 18. So, it says, is the following equation balanced? No, these numbers are not equal. So it's not balanced. Not a hard one, just to check and see if it's balanced. But you have to be able to actually balance the equation. So I do list there for you the homonuclear diatoms. We've talked about those. I bring cookies for our new home. Okay. Okay. I think it's picking back up. I had to go deal with children. Okay, so diatoms. I bring cookies for our new home. You can put those on your cheat sheet, but you do need to know which ones they are because as you're writing the chemical equations, it's important to make sure that if there's a single element that you put 2 under it if it's one of the diatoms. Okay? So how do you balance in a chemical equation? Write the equation from the words given. Remember, as you read each one, you're going to check to see, is it ionic or covalent? If it's ionic, I need to find the charge of each one, cross them, and then I have the formula. If it's covalent, you just read it from the name. Remember, we do not put mono before the first word. So if there's no prefix, no di, tri, tetra, penta, before the first word, then that means there's just one of it. If there's a word, then there's whatever number it matches with. So first thing is to decide if it's ionic or covalent. Is it a metal and a non-metal, or is it 2 non-metals? Look at where it's at on the chart. Okay. Then you're gonna write out the equation, add the atoms from each side, compare, add coefficients so that they balance. The hardest part is probably actually writing the equations from the words. So I want you to take time as you're working on this week to read through the examples of how to take the words and write them out. The first thing is to see, is it an ionic or covalent compound? You know how to do both ionic and covalent compounds. Make sure you can do that. Okay, so if we wanted to do an example of 6.4 in your book, it's page 177. Oh, there's my marker. Okay. Sodium bromide and chlorine react to make sodium chloride and bromide. Okay, sodium bromide. I need to figure out if this is ionic or covalent. Now, one key is that there's nothing in front of the word bromide. That's a good indication that it's ionic because there should be something there. If it was covalent, it would be sodium monobromide or sodium dibromide, whatever the subscript of bromide is. But there's nothing there, but to double check, we'll look. We know that sodium is Na. Can you see? There we go. And bromine is Br. And it is a metal plus a non-metal. In the front of your book, they list some column 3A, you can pretty much count as metals. You'll notice they're listed as post-transition metals, and so they're a little weird, but they're still metals. Okay, so Na has a charge of +1. You should have that on your periodic table, but remember, you can also count it. 1, 2, 3, +1, +2, +3, plus and -4, -3, -2, -1. That's how it goes across. And then the noble gases have no charge. And then bromine is -1. So I flop them and I get NaBr. Okay. Sodium bromide plus chlorine. Okay, so chlorine is just Cl. But anytime I see an element by itself, I'm going to go, is this a diatom? I bring cookies. It is the cookies I bring. So it is we have to have the diatom there. And it becomes, let's see, sodium chloride. So Na is +1, Cl is -1. They flop and we get NaCl plus bromine. And bromine is an element. And we need to check it is a diatom, so it needs to be Br2. Okay, so now I need to write out what I have. NaBrCl. Na is 1 and 1. Br is 1 and 2. Cl is 2 and 1. Okay, so let's start with, we know that bromine is going to need to become 2, so I'll do that. That makes bromine 2, that makes sodium 2. Well, if I put this here, that makes sodium 2 and chlorine 2. Now we are equal and happy. Okay? It just takes time to work through them step by step to do them. We will do more in class. As you do the comprehension checks, sorry, they're called comprehension checks here. As you do the comprehension checks, please check your answers in the back of the book. And if you struggle with them, use the book to help you figure out how to do this. Then try to do them on your own. We will go through them in the chapter review next week in class. So we'll kind of go through them, but please try to do them on your own and see what you can do. Okay? Types of reaction. First type of reaction, we talked about these a little. The back of your paper has pictures of them. Formation, a reaction in which 2 or more elements react to make a single compound. 2 or more make a single one. A plus B equals AB. Decomposition, a reaction in which the only reactant is a compound and the product are the elements from which the compound is made. So AB becomes A plus B. So it's the opposite. Formation and decomposition are opposite. Sorry. Single replacement, a reaction in which one or more element or ion in a compound is replaced by a different element or ion. So we have A plus BC becomes AC plus B. Double replacement, a reaction in which 2 or more elements or ions switch places, becoming part of the other compound. So the very first ions switch in the product. Combustion, the process by which a chemical reacts with oxygen to form one or more products as well as heat and usually light. Complete combustion produces carbon dioxide and incomplete produces carbon monoxide. If I'm saying that right. I don't have that right. Oh, yeah. Complete makes carbon dioxide and water. Incomplete makes carbon monoxide or just carbon and water. Okay. So that is it. The biggest part of this, though, is writing out the equations and then being able to balance them. So you just need to take your time to work through being able to write them out and balance them. The balancing you guys were doing great on we did in class last week. The writing it out can be a little more thought-inducing. You have to really stop and think. Ionic or covalent, then what am I doing on each side? What does this tell me? It's like a word problem in math. Everybody's favorites. Okay. Let me know, though, if you're working through it and you have questions or need some help. Bye.